Today I'll be presenting on rapid prototype development. So before I start, can I get a show of hands of how many of you are game developers? Oh, OK. I don't develop games, but that's OK. How about virtual reality? Augmented reality? HoloLens? OK, cool. So for those of you wondering what I do at NASA, I fight alien robots, as you can see. Yeah. So my name's Yasmeen, and this summer I kickstarted a HoloLens initiative at NASA's Kennedy Space Center. And with my partner Cameron, who couldn't make it today, we used rapid prototype development to finish what would have been a 4-month project in about 8 weeks. So that's Cameron, and he's busy right now taking a test. Yeah. So what is rapid prototype development? Well, rapid meaning fast. Not a lot of things at NASA happen quickly. So it was kind of hard for us to start our project there because missions take up to a decade to happen. Wait, oops, yeah. But obviously, like with technology changing so quickly, we didn't have 10 years or even 18 months, or just like a few days might be too long sometimes. And prototype, meaning just a simple proof of concept, like a work in progress. And development, meaning in software, you have like a group of people that you have to work with and use the resources that you have available to you and the skill sets to create something, create your prototype. Yeah. So at NASA, there were already a bunch of different AR and VR initiatives. So Cameron and I had to go around center and figure out what was already being done. One of the places we first visited was the Ideas Lab, and people there were building their own custom headsets with heads-up displays, and they built their own because they wanted to use custom sensors and write their own software. And they found that commercial off-the-shelf products weren't good enough for them. So that's one of the things that they built. And the other place that we went to was this guy's AR/VR lab. So he put a leap motion on his Oculus Rift and used it to control that robot that you see. So he also put Kinects all around him to track his motion in that little area. Yeah. So outside of KSC, there are more popular projects. So the one on the top left is what JPL made, like the Mars Rover. So they show that to the public, and on the lower right-hand side, you can see astronaut Scott Kelly. So they sent up a HoloLens to the International Space Station, and he used it for remote training and guidance. Yeah. We ultimately decided to use the HoloLens for our project because we didn't want to have to create something from scratch, and we figured out what they already built was good enough for us. And we also didn't want to work in VR because we wanted to interact with the environment around us. OK, so our customer was the Launch Services Program, LSP, also known as Earth's Bridge to Space. And they're responsible for launch operations and mission assurance. So they just make sure that the rockets launch properly. The average age of people working at NASA is like 40 to 50 years old. So I don't really understand them, but yeah, because that's as old as my parents or something. And they're not really open to change because since everything that they work on is like a decade long, they don't really change their ways often. So introducing something new to them was quite a challenge. So the first thing that we did when we were starting our project was demo the HoloLens to the entire Launch Services Program in the mission briefing room, which is like about the size of this room. And we didn't have the stuff that we needed, so JPL helped us out. We only ordered our first HoloLens after that demo. And we didn't have any of the software that they had, so we had to build ours from scratch. So you have to ask your customers what they want from the product, and to help them figure out what they want, you have to show them what the HoloLens can do. So we started off by demoing the HoloLens to different people in the Launch Services Program every single week. So at the end of the week, we would show them what we had accomplished so far, and they would give us feedback. So we wouldn't let them leave the room until they wrote down a suggestion or a comment on a Post-it note and put it on the wall. So that was like a good way to force them to come up with creative things. And it was funny because they liked what we made, but they also enjoyed the games even more. So you could just see them like running around the office, playing with Robo Raid, and also killing aliens, aliens and robots. Yeah. So, okay. Sometimes coming up with a simple solution is best. Given a problem, you can probably come up with like the first thing that comes to your mind, and like for rapid prototyping, that is probably the best way, because you don't want to spend too much time to come up with a complex solution when one could just be staring you right in the face. Like, it's not really rocket science, you just have to come up with something simple. Well, yeah, in our case it was, but so I'm going to show you two examples of simple solutions that helped us solve meaningful problems. So the first thing that we worked on at NASA with our project was the OSIRISRex mission, which launched on an Atlas V rocket in September to go to the asteroid Bennu and collect samples. So one of the problems with this is the the spacecraft could not be hit by sunlight on certain areas at certain angles. So one of the flight analysts came to us and told us that he had trouble explaining the angles to the engineers through numbers. Because it's NASA, like they just give you papers with a bunch of numbers and you have to figure things out. So what we did is help them visualize this. So I can't show you what the angles were, because we put cones around the areas with the angles, but this is the 3D model of OSIRISRex that we used, and we put it in Unity and turned it into a hologram. And then from there, we asked the engineers what would be most intuitive to them, and we tested the different hand gestures and used speech to change the controls and test them out. And it actually helped them a lot, because placing the spacecraft into the room right in front of them allowed them to visualize something that they couldn't normally see. And they could actually rotate it and then go underneath and view it. It was a lot easier to see it as a hologram than in real life. Okay, another example is a project that I made at a hackathon. So, has anyone heard of pen apps at UPenn? Okay, one person? Yeah. So at pen apps, we had about 48 hours to come up with an idea for an app, and it was the second day and we still didn't have anything. So randomly, I just thought of making this app to help people learn sign language and also help deaf people understand what other people are saying. So it was very simple. All we did was take speech to text and then translate that to sign language using GIFs and 3D hand models. Yeah. But apparently, when I told this to somebody, another HoloLens developer, he said that people were already working on something like that, but then we released it first while they were still animating the hand motions for as many signs as they could. All we had to do was go online and pull the GIFs from a website of that guy who had a bunch of them. So that was a very simple solution to a problem that other people overcomplicated and then ended up missing out on the opportunity to release this application. So build on what works. In other words, don't reinvent the wheel. So if you're a HoloLens developer, you probably know of Holo Toolkit, for Unity especially. And we use that a lot for all of our projects. So it provides you with all the things that Microsoft already made for the HoloLens. And you don't have to recreate that because they already made it for you. So you shouldn't waste your time worrying about the small things when you could be focusing on solving the actual problem that you wanted to solve in the first place. And an example of how we used this is fizz filter. So last month at MIT's Reality Virtually Hackathon, my team and I came up with the idea to use the HoloLens's spatial mapping capability to understand the features of a room by scanning it and then placing objects around the room based on a theme that you would choose. So we used the spatial mapping first and then the hand gestures to complete this application, and we didn't want to create that from scratch when it was already a feature in the HoloLens that we could emphasize. So another example of building on what already works is Call of Duty. So I don't really play video games, but Cameron does, and he says that they figured out a recipe that works and built upon that recipe. So they already had the first game and then just recreated a bunch of times because people were buying it. So why not, I guess? Yeah. So they already had the basis of it. So all they had to do was just add on and sell it again a bunch of times. Yeah. So setting goals helps you break down a big task into smaller, more manageable tasks. So with our NASA example, we set weekly goals that helped us reprioritize what we wanted to do, so we could stay on track and still accomplish things. So that, like, the setting goals thing is what helped us finish our project in about like half the time, because we're focused on, by the end of the week, we need to have this finished. And it doesn't matter if we don't have the bigger things, but like just a smaller thing, just to show our stakeholders that we are actually making a progress on what they asked for is very important. Otherwise, they'll stop investing in your project, and then you'll have nowhere to go. So towards the end of our project, we used the HoloLens to place a spacecraft in the room that it would be processed in. So that's the OSIRISRex spacecraft, and that's the Payload Hazardous Servicing Facility, where they would clean and process it before it launched. So what we did was we just partnered with the Boeing Design Visualization team, who did LiDAR scans of all the buildings on center, and they gave us the 3D models to place our own models into them and allow the managers of the mission to view that. And it helped them figure out if they could process multiple spacecraft at the same time comfortably. And that would help us save time and be more efficient when processing spacecraft, so we could get through more missions quickly and save NASA lots of money. So one of the future goals that we had was to use spatial mapping to scan the room that you're in and then figure out how to overlay the walls of the PHSF into that room and then place the scaled model of the spacecraft into the room that you're in. So that way you don't have to dress up like I did in that bunny suit, because it took a really long time and I couldn't find a size that was small enough for me. So I was like floating in it, and yeah, it was kind of uncomfortable. And you also only go in there for like a few minutes if you're just wanting to check out the spacecraft. So like, why waste all of that time and energy when you could just view it in front of you virtually? Okay, so I put together a guide on how to develop a basic application for the HoloLens at the end of the summer, because when I was leaving, there wasn't anybody else at the Kennedy Space Center who knew how to develop for HoloLens. And I wanted to save them all the time and effort by teaching them very quickly and easily how to create a basic application so they could just build off of that and create more prototypes rapidly. So it's free and it's online, and I created a GitHub repo, so it's open source, and if anybody wants to add more HoloLens resources, you can just give me a pull request. And I'll probably be working more on that as I develop more for the HoloLens. Does anyone have questions? No?